Hello dear students, welcome to the third video in the series Organic Chemistry Some Basic Concepts. In the first two parts we have dealt with three effects, the inductive effect, electromeric and mesomeric effect. An honest advice would be to go through those videos first in order to understand the next effect or the next concept called as resonance. Resonance simply would mean a repetitive pattern or some pattern which repeats for a longer time. When you strike a chord, the same pattern being repeated is what we call as resonance. In order to understand the concept of resonance, I'll take a very simple example of a game which is being played between two children, A and B. And there comes a third child. They are tossing the ball from one to the other. The monkey in the middle, that's what the game is called. The monkey in the middle tries to catch hold of the ball. Take a second example, A, B, C and D. Now there are four children playing the game. They have a monkey in the middle. This child has to grab the ball which is being tossed around from A to B, B to C, A to C, D to B. So many combinations are possible. Now in which case is there a possibility for this child to get hold of the ball, the monkey to get hold of the ball? The scenario 1 where we have two children, or the scenario 2 where we have four children tossing the ball around. So obviously here it will be the second scenario where the ball is being tossed around between more number of children. Similar is the behavior when we talk about resonance. Resonance is a phenomenon which takes place when there is interaction between two pi bonds or pi bond and lone pair of electrons. Just like mesomeric effect. Here we have taken the example of an interaction between lone pair of electrons and the pi bond. The lone pair of electrons from oxygen are shared with the carbon of the benzene ring, carbon number 1. In order to be able to understand clearly, we will number the carbon atoms 1, 2, 3, 4, 5 and 6. Now this carbon number 1, it forms a double bond with the oxygen atom. Because oxygen has shared its lone pair of electrons with the carbon, it acquires a positive charge. In turn, the carbon number 2 has to withdraw the pi bond of electrons from here because our carbon number 1 in such a scenario otherwise would have 1, 2, 3, 4 and 5 bonds, which is not possible because carbon is tetravalent in nature. Carbon number 2 takes away the pi electron cloud on itself. Now it can't stay like this for a long time. So either it forms a double bond with the first carbon again, or alternately what it does is it forms a double bond with the third carbon atom. So we have carbon number 2 and 3 forming a double bond using the electron pair it has got from oxygen. In other words, this double bond has to go. So this is double bond and here the electrons are now left over carbon number 4. So what we have over here is this electron pair has come here, whereas this electron pair has gone to carbon number 4. There's another possibility now. Carbon number 4 either again forms a bond with carbon number 3, in which case we'll have the first the structure, or alternately it can form, that is carbon number 4 and carbon number 5 can form a bond. When it forms a bond, we will have carbon number 6 acquiring the electron, so it becomes a negatively charged species. Our oxygen still remains positively charged with its electron pair. And now the double bond is there between carbon number 2 and 3 and carbon number 4 and 5. In all these structures, if you see, we have not added or removed any electrons from the structure as such. The number of electrons, the number of atoms, everything remains the same. It is only the arrangement of electrons within the structures which have changed. So the possibility of the electron remaining in this structure is high. That is why this phenomena is called as resonance, wherein the electron pair is getting distributed over or spread over the entire structure rather than remaining localized, rather than remaining fixed over one particular atom. So in resonance, it is the delocalization of electrons which is taking place. 1, 2, 3, 4. These are all structures of the same compound. They are differing only and only in the way the electrons are distributed. The structures, if you notice, they are all the same. Hence, they are all equivalent structures. To denote equivalence of structures, we indicate it by an arrow, by double-headed arrow. So canonical structures are represented by double-headed arrow. So what is our actual structure? Our actual structure is actually none of this. It's actually denoted by a single structure wherein we've got a positive charge on the oxygen and the negative charge is spread over the benzene ring. This is what we call as the resonance hybrid form. A mixture of the different forms, a combined form which represents the canonical structures. If a compound undergoes resonance, that means the electrons, or you will come across cases where we talk about the positive charge also. This cannot be deprived of its charge very easily. That is why such structures will be very stable. While drawing these resonance structures, you have to remember that these structures are always planar. They will be in the same plane. Like we've taken the example of benzene. All our carbon atoms are in the same plane. You do not have to disturb the position of the atoms, but it is the position of the electrons which will change. These are some of the rules for resonance. What is resonance energy? There is a term we've mentioned over here, resonance energy. What is resonance energy? It's simply a measurement of the stability that has been provided to the molecule because of resonance. So resonance energy is nothing but the energy of the compound minus the energy of the most stable canonical structure. We have to remember that each of the forms has its own contribution to stability or to the resonating structures. The negative charge, if it is on the more electronegative atom, the possibility of it contributing towards resonance or contributing towards stability is much more than when the electronegative atom has a positive charge. See an example over here. We've taken an example of carboxylic acid over here, RCOH. One possibility is oxygen takes up the pi bond of electrons, acquires a negative charge, and it has its lone pair of electrons. The other possibility is it gives these electrons, and what do we have is here is carbon with a negative charge, whereas oxygen acquires a positive charge. So in this case, what will happen is this structure wherein oxygen is on the more electronegative oxygen, the chances of this structure stabilizing the resonating forms or or this particular compound are much more. It is just like if during the passing of the parcel, if you have the ball with a person who has greater strength, will be able to retain the ball much more strongly and much more longer as compared to if you have a ball being tossed around by people who are weak. Second, less separation of charge. Less separation of charges. Simple, take an example. The ball is being tossed between A and B. The other is the ball is tossed from B to D. So in which case will this be able to grab the ball more easily? The monkey will be able to grab the ball much more easily when it is being tossed from B to D rather than from A to B. In other words, lesser is the separation of charge, more is the contribution towards resonance. A very important point, and it is something which you will come across very, very often when you are dealing with the reasons on the behavior of organic compounds. More the delocalization, more the stability. More you share, more you pass around the ball, greater are the chances of the monkey remaining in the middle rather than getting hold of the ball. So more is the delocalization of the charge, more is the stability. If I talk about the stability of phenol and I talk about the stability of carboxylic acid, of course, phenol will be much more stable. Carboxylic acids, on the other hand, are much more reactive. Reactivity is something which is to do with electrons. So they are not so stable. The chances of the electrons remaining with carboxylic acid are less compared to the chances of those electrons remaining with phenol. Because in the case of phenol, this is an entity in itself and it is making itself stable by sharing the burden with all of them. Whereas in the case of carboxylic acid, there are lesser number of atoms to share that load. So more the delocalization, more the stability. More the delocalization, more the number of canonical forms. Greater the number of canonical forms, more is resonance. Greater the resonance, lesser will be the reactivity. Last but not the least, more number of covalent bonds. Very simple. I've taken an example of benzene and carboxylic acid. Here, if you have greater number of double bonds, means the chances of the electrons changing positions is higher. Their possibilities are more. You can also write benzene as 1, 2, 3. Whereas in the case of carboxylic acids, let me draw the structure of benzene much more clear. So we have, this is the second form of benzene we've got over here. Whereas in the case of carboxylic acid, the possibility becomes less because there is no ring structure over here. If to this benzene I attach some group like OH, CHO, NO2, the number of resonating forms will be much more. Here benzene itself has two forms, but if it has like a group like COH, what we've got in the aliphatic, the number of resonating forms becomes even more. For example, in the case of phenol only, if you notice, there are 4 resonating forms. So the simple rule is more the number of covalent bonds, more will be the release of energy, more will be the formation of bonds, more will be the canonical structures, and greater will be the stability. For a write-up on this note, please refer to the site Learning Chemistry is Fun. You'll find a complete write-up. You can go through the video again, and the best is if you can teach this concept further. It will make understanding of this topic much more simpler. Hope you enjoy the video. Let me know your feedback. I have not written all the points on this board. The purpose of this video is to make you understand the concept, not to give you notes. So if you want a write-up, if you want some written material, please refer to the website. Have a good day.